The third of our conditions that we can change is temperature, and the most important thing to look for on this type of reaction is when written out from left to right, reactants to products, is that forward reaction exo or endothermic? So is it exo or is it endo? Because that is going to change your answer. And that's the most important thing to think about, and the first thing you should always write down in your answer. The forward reaction is, and then tell me whether it's exo or endo. So if the temperature is increased, according to Le Chatelier's principle, then the system's going to want to cool down. Which sort of reaction cools you down? Which one does the thermometer go down in? Well, that's an endo. So if the temperature is increased, we're going to go in the endothermic direction. Now what we need to remember as well is that if a forward reaction is endo, then going right is the endothermic direction. But if the forward reaction is exo, then going left is the endothermic direction. If the temperature is decreased, then we're going to go in the direction of the exothermic reaction. So we have to remember that if it's plus in one direction, it's minus in the other, so this is going to help us with our answers. So let's have a look at our examples. Here we've got one. So the first thing that we would do is go and decide whether it was exo or endothermic. Okay, so we've decided this one is exothermic. So the first thing you should write down is the forward reaction is exothermic. Okay, so this is if, it says if because we're talking about general statements here, but the first thing you would write down is the forward reaction is exothermic, so an increase in temperature. So what does exothermic mean? It means that as we go from left to right, it gets hotter. That's what exothermic means. And as we go from the backwards version, will be our endothermic direction. It's going to get colder that way. So if it's forward exo, then in the reverse reaction it's plus 92.4, it's endo. So if the forward reaction is exothermic, according to Le Chatelier's principle, I heat it up, it's going to try to cool down. So it's going to go in the direction that allows it to cool down. So it's going to shift to the left to oppose the change. How does shifting left oppose the change? Well, when you go in the endothermic direction, endothermic reactions, remember, look like this on an enthalpy profile diagram, like that. They absorb that up arrow, they take in that heat. So as you're heating it up, they oppose the change and absorb the heat. They shift in the endothermic direction. So if the forward reaction is exothermic, we're going to shift left when we heat it up. So if we want to increase the yield, we don't want to be heating it up because it's going to go away from ammonia, so we need to use a lower temperature. Let's have a look at our next example. So in an exam, you would not be told that this was endo, you'd have to figure that out for yourself. So as we go from left to right, it gets colder. It absorbs heat. And as we go from right to left, it releases heat, because that's the exothermic direction. So if the forward reaction is endo, an increase in temperature will cause the equilibrium to shift to cool it down. Because you're heating it up, it's taking its coat off and getting cool. So it's going to shift to the right. And we have to explain using Le Chatelier's principle, so to oppose the change. And when we heat it up, we need to absorb heat. We need to absorb the heat that we've released into the environment. So absorb the heat. Therefore, if we want a good yield, we want to heat it up, so we use higher temperatures. And then just remember that heating it up always increases the rate, but it increases the rate of the forward and the backwards different amounts, and that's why we shift left or right. Now just tagged in the bottom, but needing to make it very obvious, let's find some way to make that stand out. Let's put some stars around it. It's just that it doesn't need a whole page to itself because there's not a lot there. We need to remember that catalysts increase the rate of the forward and the backward reaction by the same amount, so they have no effect on equilibrium position. It just gets there faster. So if you're asked to explain the effect on position of equilibrium of a catalyst, you say no effect. If you're asked to explain why, you have to say rate of forward and backwards increase the same amount. That's the most important point there.